I want to start this talk by asking you guys, do you remember the 90s pop hit That Don't Impress Me Much by Shania Twain? Yeah, you do. That's great. But if someone's afraid to not admit their lacking knowledge of 90s pop, here's a short summary of it. If you're a rocket scientist, that don't impress Shania Twain much. And if you have a car, that don't impress Shania Twain much either. But if you're Brad Pitt, that don't impress Shania Twain much either. And to be honest, I understand Shania Twain a lot. At the time of this song's release, she was 32 years old. And she had probably spent the last 10 years seeing guys come up, brag in, but never quite living up to their own hype. And to take a philosophical turn, isn't our life as JavaScript developers a bit like Shania Twain's life? For the past 10 years, we have seen JavaScript frameworks bursting onto the scene about every month, bragging about their own, honking their own horn guns ablaze, saying that they're the best, but never really quite living up to their own hype. But, my friends, 2019 was a special year. It was the year that a very special work of art was released, something that will probably you will tell your children about, like a milestone in your life, and that was the release of the movie Ad Astra, starring Brad Pitt as a rocket scientist who has a car. And that actually did impress Shania Twain much. But there was some other small piece of news in the JavaScript world, and that was the release of the Svelte language. Now, before I tell you about Svelte, I want to talk a little bit about me. I'm a developer, and I have been at Knowit Objectnet for the last 2.5 years. And I'm currently stationed at NTNU, a public transport company where I make an Electron app. That is React-based, and I'm a front-end developer in that project. I have been using Svelte for about half a year. And during that time, I've made a craft group in Knowit Objectnet called Svelte Guild. But we accept people of all creeds, so just send me a mail on my email address if you're interested in joining, and I think you will be by the end of this talk. Now, you may be familiar with some of my Svelte work actually, because last week I made a climate calculator that made filling out that boring part of the climate form a little bit more fun and a little bit more animated. And if you've just joined our company because you're very young, you might have played my whack-a-mole game in Svelte. Both of these I've had design work help from a designer called Birgitte. I just have to give her credit because it's very good. She works with me at NTNU. Now, this talk will be about what Svelte is, and it'll also be a little bit about the differences between Svelte and other frameworks, and we'll look a little bit at what happens under the hood of Svelte. But this will not be a full walkthrough of Svelte syntax, and I can't make a full technical presentation of Svelte. That's just because we have 30 minutes, but I'm sure you will be encouraged to check it out yourself, and it's very easily learned. So, questions at the end, because like Svelte, we're packing a lot into a little bit of space. So if you have to leave now, the moral will be that Svelte is small, fast, and fun. So strap in, like Svelte, this will be fast. I think now that I've shown you a little bit about what it can be used for, let's just take a small look at how a Svelte file looks. Now, Svelte is primarily a way to... Oh, I have to press the link here. No? There. Okay, so Svelte is primarily a way to write components, and it comes with a set of libraries that makes writing these components much easier. Now I've made a welcome page for a city and a little control panel for it. So I could be the mayor of this town. I've said welcome to Bergen, but I want it to be another gloomy city. So I'll call this city Gotham, for instance. And we also have a number of villains in this city that are stored in an area here. And I also have a variable here for whether we turn on our bat signal. This is located within the script tag, which is where logic and data is stored. Below it, I have a style tag which affects the background color of the body. Now, this could have been a slightly grayer color or perhaps a more blue or green one, but I've styled it in a very minimalistic noir way. So this is style tag, and if you're familiar with CSS, you'll see that it looks like CSS, and this looks like JavaScript. And below is the HTML template, which renders the data to the page. Now, you inline data by putting it between curly brackets, and if a curly bracket starts with a hashtag, there's some conditional going on, like here. So if the bat signal is on, then we will display this image, but not otherwise. So let's see what happens when you turn this bat signal on. Yeah, then we get that image. Now, the way this bat signal was turned on is because we have a bind checked here. If you're familiar with the input type checkbox, you'll know that it's written as checked, and then you write true or false. In Svelte, you bind the value of the checked attribute to the Boolean value of the bat signal on variable by writing a bind colon thing. And below here, jumping ahead, we also inline the number of villains in this list, and we have a loop which is written with each, assigning each villain to a villain variable, listing up its name, and that's below here. We also have an on-click function. For technical reasons, it's written in this way with a colon, but simply we take the villains array and we splice off the first villain. So let's catch the most wanted villain. Joker disappears, and now there are 0 villains wanted. We have solved this city's problem. Now, I'm going to introduce a concept that you won't understand the point of right away, but I just want to do it now. So you won't see the point of me talking about these dollar signs now, but I'm going to refer to it later. So let's just do it now. Now, Svelte has something called conditional statements, which are, not reactive statements, which are marked with dollar signs. Now, what a reactive statement is it's a piece of code that is only run when one of the things it depends on changes. So the number of villains variable is assigned to once the villains array changes. And the same thing with these console log statements is they're only run once the variable they depend on is changed. So once the app starts, all of these are assigned, and that's why they're printed out. But if I turn the bat signal on and off, like this, the bat signal on is printed out. If I catch a thief, there is no bat signal console logging, but we still console log the villains variable and the number of villains. And actually, once the villain array is empty, the number of villains isn't printed out because it's always 0. So it's actually not run if the variable has the same value. Now, you won't see why this is cool until later on, but I just wanted to show you. Okay, so if you're anything like me, once I heard about Svelte, you're probably a little bit underwhelmed right now, because we already have React and Vue. Why do we need Svelte? I have 3 reasons for this. The first thing is that size matters. Svelte's commitment to a small size is in its name itself. Name Svelte means slender and very graceful, suave. And I think talking about this, it's better to just show you some numbers, because I could stand here and say words, but it won't describe what's if I don't show you any quantitative data. So the best quantitative comparison of a lot of frameworks I found is this article by Free Code Camp, which is a comparison of the real world app in different frameworks. Okay, could you raise your hand if you're familiar with the real world app? Okay, you are. That's nice. So that was my guess. But are you familiar with To Do MVC? Can you raise your hand if you are? Yeah. Okay. No biggie if you aren't. So, but To Do MVC is really as like an implementation or a specification of a to-do list app that can be implemented. Or the point of the app is that it can be easily implemented in a lot of languages. So if you're launching your own framework to show the world how easy and good your framework is, then you implement To Do MVC in your language, and people are impressed and cheer and everything. But the thing about To Do MVC is that it's not a very real world app, hence the real world app, which is its sequel, because the To Do MVC just contains data in the browser. It doesn't fetch any data or post or something. So To Do MVC is a blog app, which is a copy of Medium. So you fetch posts and you post things and you fetch tags and you filter. So it's really a more comprehensive way of comparing your favorite framework to some other framework. Now these the frameworks that you see the logos of on the left side were evaluated by 3 different criteria, which were performance, lines of source code, and bundle size. Now they were all quite equal when it came to performance, which is how fast they lead to repaints on the screen, how long do they take to update things in their stores, and the like. But how they differed were mainly in the last 2 criteria. That's what I'm going to talk about now. The first one is the number of source code lines. And you may be asking yourself, why is that an indicator of quality at all? But the thing is that as developers, bugs grow quadratically with the number of source code lines, because the more lines of source code you have, the greater the probability that you will screw up one of them. And not only that, but why does it increase quadratically? That is, if there are twice the number of lines, then there will be 4 times the number of mistakes. Well, that is because bugs occur when a new line is wrong or when it contradicts an old line. So if you're writing this loop, so you could make a mistake assigning the variable or referencing the variable j there or something, and you could make a mistake in the if statement doing the modulus 3, for instance, but you may also make the mistake of contradicting an assumption that you've made in the previous line or some piece of shared knowledge. Now, if you're familiar with graph theory, or if you're not, I'll take my time and help everyone. So in graph theory, you can you introduce concepts as nodes and the connections between these concepts as what's called an edge. So imagine a 1-line program that would be a single node. And if you have 2 lines, then you would have 2 nodes and an edge between them. So these 2 lines represent 2 lines in a program. For instance, the for and the if statement in the last program. And the line here shows the potential for an assumption to go wrong between them. So when you have a 1-line program, there's just one place where a mistake can occur. But when you have 2 lines, you can have a mistake occurring in the line or in the connection between them. And if this number goes up to 3, you all of a sudden have 6 places for a mistake. And when you have 4 lines, then you have 10. And if we double from 4 lines to 8, then we have 36 places where a mistake can occur. And this is not just something that I'm making up. This has been empirically proven again and again, that as the number of source lines increase, the probability of bugs occurring goes up quadratically. Now, this does not mean that you should rewrite very good statements like this to unreadable single-line statements. But it means that if you want fewer bugs, choose a language that allows you to express things in fewer lines. And let's see how these frameworks fared in terms of this. So this is the lines of source code, excluding white space. Now, at the bottom of this ranking are a few type-safe languages. So the assumption does not necessarily hold. It holds within a language, but given equal, like restraints on the language, like type safety, languages are quite comparable. But yeah, let's look at the top with quite comparable languages. So you can see that Reframe, AppRun, and Svelte are in the top with about 1,000 lines to implement the same app as what Vue and React does in 2,000 lines. And that means that if you're implementing this app in React, there is a 4 times higher probability that you will make at least one mistake than if you're implementing it purely in Svelte or in any of these other contenders. Now, you may not make those mistakes because you have good tooling, but there is a greater risk simply because there's more information for your head to process and for your coworkers to process once they read the app. Now, over to a criteria that users care more about, which is bundle size. Bundle size is important because of download time and cost. We all know that. But it's also important because of parse and execution time. So when your user downloads a bundle that is 100 times or 10 times larger than another bundle, it isn't just 10 times more expensive and time consuming to download, but their computer actually has to parse 10 times more code. And that means if the bundle is 10 times larger, then they have to wait 10 times longer. at least if that's the only factor. And what does this mean? This means that if your bundle is small, then you will have a user base that is larger because people have old phones. And also there is a really new minimalistic hardware, such as these card terminals that don't have the power to run massive front-end apps, but that could shoulder a small front-end app. And how did they fare? Well, I'll just show you it at once, and of course, BOW! Mind-blowing! Svelte at 10 kilobytes. For a comparison, that picture is 24.63 kilobytes large. So here is Vue and Elm at like 41.29, and the React Redux implementation is at 200 kilobytes, and this is massive. This is a massive difference. I've already told you why this is a great difference. This means that your user base will grow larger and you will make more money. And also your server costs will go down. But why is Svelte so seriously fast? Well, this is because Svelte is not regular JavaScript. Svelte is a language that compiles to JavaScript. Now, this does not mean that you can't use your existing JavaScript things. They can be imported. But Svelte is really a compiler. And what is the difference between a compiler and a framework? Well, a framework is really just a backpack or a Swiss Army knife of functions that you ship. Now, there is tree shaking and all that. You can remove code, but largely there is a backpack that your app has to shoulder once it goes out into the world, while compilers can give you just the code that you need. And now we're finished with the part I call size matters. The next thing is that speed matters more. I already told you about download speeds, but let's talk about drawing speeds. To tell the tale of Svelte and drawing speeds, we have to go back in time. We have to go way back to the year of 2004. Now, 2004 was the year that the W3C released the DOM specification, which is the document object model. That is really a way to represent the tree that is your HTML document in a representation that your JavaScript can manipulate. And this is really no big deal. It's just methods on nodes in JavaScript memory that you can use to manipulate the DOM and redraw it. Really doing anything. Now, 2004 was a much simpler time. It was the year that the Moldovan band Ozone spent 17 weeks on the top of the Norwegian Billboard with Dragos Dedente and Vespertina. We were also certain that George W. Bush would be the least competent president in US history. And also, Google Maps looked like this. Now, in the years since 2004, things have really started to change. There was this strange service called YouTube coming out in 2005, and then something called the Facebook in 2006. And then in 2007, Steve Jobs stepped on a stage like I did, and he said, I have an iPod, a phone, and an internet communications device. And if you see that show, people are like, they're cheering for the first two, but they don't really understand the impact of the last third, which is really what changed everything. The internet was all of a sudden in our pockets and in my hand here. And the internet became an asynchronous place. That is where you load a page and then you later load data. And a misconception started to spread, which is that the DOM is slow. Now, I'll explain to you why this became a misconception, which is when you re-render stuff because of asynchronous operations, your page has to redraw and reflow all text and elements once the data reaches you. So if, for instance, I fetch that logo later due to some asynchronous call, all the text would have to be reflown down. Or perhaps if I had all of a sudden loaded that sidebar as an asynchronous element, then all the text would have to be reflown. And it would have been much better if that operation could be done in one chunk, that is both the logo and the sidebar appearing at once, because then you would only have to redraw once. And that is what caused the DOM to be slow, is that you had lots of data coming in, each one causing a redrawing of the page. So unnecessary redrawing is slow, that's the thing. So we needed a way to minimize DOM manipulation operations. Now, a few years later, in 2013, Facebook had changed its name to just Facebook, and it released something called React. Now, what was groundbreaking about React was its introduction of the virtual DOM. Now, what the virtual DOM is, it's just a representation of the DOM inside JavaScript memory, without all the methods. And what this is useful for is that when you receive new data, React can in memory perform all the manipulations that it's supposed to do on the DOM. And once it's found out, okay, these two things have to be deleted, then it can reconcile its virtual DOM with the actual DOM and perform the minimal amount of redrawing. So you stop wasting redrawing time. And this is so successful that it has been mimicked by almost everyone, from you to Elm. Now, this has effects on the running time. Actually, the effect is not as large as it possibly could be. It's ON, and that means as the number of DOM nodes increases, so if it increases linearly, then the drawing time or the running time increases with the same amount of time. You double the amount of nodes, you double the comparison time. And this is way better than the cubic running time it wouldn't have been with the tricks they have implemented. So it's quite smart. And if you're interested in it, search for React reconciliation. But you can push React into edge cases where this starts affecting your application. So here is an example to scare you. You will rarely go to places like this in real life, but you might go there. So, this is taken from a presentation by the creator of Svelte, so I have to warn you that it's slightly biased towards Svelte. But okay, so what I'm gonna do here is I'm gonna type things into this page. I'll just full screen it like that. I'm gonna type things into this input field, and the longer the content of this input field is, the more random nodes will be added to that graph, and all the existing nodes will be deleted. And what this is going to do is it's going to make React's reconciliation algorithm break under its weight. So I'll just start writing, and I'll tell you what I'm writing as I write it, and we'll see the delay. Hello, I am at Knowit Developer Summit. Very cool. Oh no, this is shit. Okay, so this is actually the delay, and now I'm very surprised if it could finish by the time I close this tab. Okay, so this is the effect of a large virtual DOM change. Now, to summarize where we're at. So the actual DOM spends no time comparing, but it wastes drawing time, while React has minimal drawing time and spends time comparing. Now, if, to say it in the lingo of 2004, there was only something that could give us the best of both worlds. Now, you already know what the title of this talk is, so I'm not going to hold you. It is Svelte. So here is the example again, implemented in Svelte. Okay, here we go. We're still experiencing little delay. Things are working out all right. Okay, I'm just going to start typing random things. Blah, 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 blah. Stop. Ah. Well, much easier. And the reason for this is what you remember, that $sign part I told you to remember. The thing is that under its hood, Svelte is very pertinent about making connections between different variables and the data that is displayed on screen. So when data changes inside its stores, it knows exactly what parts of the DOM to update. And because of some tricks under its hood, it also batches the DOM update operation so that it's not like 3 redraws because 3 variables changed. It actually knows, okay, these 3 things have changed, I will make these updates, boom. But it doesn't have to compare with the actual DOM. It can just delete the existing DOM nodes. Okay, so this is where we are. So we're at 2/3 of this presentation. And to summarize, I've said that size matters and that speed matters more, but what matters most is fun. Having fun and making the users feel that things are fun. And what is fun? Animation is fun. Now, you don't really see the impact of this until you have a user-facing operation that needs animation, and how easy it is to get help from Svelte to have animated content. But just to show you with the example that I hit upon earlier with the Gotham City page, it is as simple as just adding a tag or an attribute onto your HTML. So now I've added the transition directive and used blur. So the transition blur will lead to a blur transition. And down here on the villains, I've also used the transition fly, so they will fly when they enter and exit the DOM. Let's turn on the bat signal. Boom. Slight blur, and when we eliminate the villain, they fly off the page. Now, I won't talk too much about it, but if you remember the climate calculator and the mouse whack-a-mole thing that I showed you earlier, all of those are implemented in pure CSS animations. Or I have to make one correction to that. In one of them, I'm using a special store called the tween store to tween values. So in the climate calculator, when you drag a slider, like, okay, I'm using a cart 3 days a week, the animation relies on the value being tweened. So you can check this out for yourself. The tutorial on it is really good. And if you're interested, you could also go to this game at mos.knowit.no, which means mash in Norwegian, and check out the code by pressing the GitHub thing up in the right corner. What is cool is that this is CSS animation, and CSS animations can be hardware accelerated. That means that these animations will look cool to your mom with her old Android phone, and not just your developer friends at home. Okay, I've touted all of Svelte's good egenskaper, good attributes. So let's just have a look at who's using this. Now, Svelte came out in 2019 in its mature 3 version. So the number of companies using it actively is not large, but it's growing. I held this presentation in its first form in October, and the list was this long, and now on Thursday, it had grown to this length. Now, if you're a keen Knowit observer, you will know that Entur is one of the companies that we serve. And I have the honor of having put that name there because our feedback form in the user app is now implemented in Svelte. And the reason for implementing this in Svelte is that we needed our feedback was very bad. And we needed a lot of animated hints. Like when you're in a certain text box, you need the hint that, okay, when you describe this problem, you should include the following things. The problem with our users is they don't read text. When it's statically there, they just skip it. But once it was animated, it suddenly started improving. So that's great. And Svelte has been a great help to us. And they have very old machines. That is why we have to select Svelte, because or React animation libraries usually do it in JavaScript, and that appears slow on their page. Okay. Now, Svelte is not backed by any great or any big company, but it's backed by a vibrant community. And you're okay to join us. It's not that hard. I have made 3 updates to the documentation, and that has placed me right there. If you make 4 commits, then you can get ahead of me. If you want to start, I recommend you check out the tutorial. It's very easily done, and it's done in browser. And you can also check out that mos.knowit.no thing. Play it. 42 points is what I reckon most people get, so see if you can beat that. And also use the climate calculator to skip that boring survey. And join the rest of us making things that will impress Shania Twain much. Thank you. Okay, I think we have 2 minutes left for questions. Great, you will get a microphone from that guy. And I have to drink some water.
Does it play nice?
And yeah.
Does it play nice with Internet Explorer?
Internet Explorer?
Yeah.
That I don't know. I think I've looked at some of the compiled code, and it rarely uses any modern JavaScript. I don't have much experience with developing for Internet Explorer. Is that the criteria, or do you remember any other criteria off the top of your head that are determine the success of an app?
What I'm most interested in, is it ES5 compliant?
I think so.
Yeah.
Yeah, I do think so. And you could also transpile. The code is pure JavaScript, so once you have your Svelte output, you could transpile it.
Yeah.
Yeah. And also one thing that I tried to push into this slideshow and that I didn't find a natural place for is that those tags that you see, like the script tags and the style tags, you can actually outsource the work to something called preprocessors. So if you rely on TypeScript or a special CSS preprocessor like less or SAS, then you can actually outsource those tags. To read up on that, note Svelte preprocessor and Google it. Yeah. Anyone more? Great. Seems we will have lunch soon. Yeah. Don't be afraid to speak to me during lunch or reaching out to me on that email there. If you want to join us, or at least have someone to talk to about Svelte, some place to reach out for experiences. And I'll try to include you in our Slack group if you have a Slack account. Okay, good.